Previously, we looked at how to factor trinomials when the coefficient of this first term, the x squared term, was 1. Now we need to look at how to factor when the coefficient is a number other than 1. So here's an example here, 2x squared plus 8x minus 24. Now the first thing that you should always remember when factoring is always look if there are common factors first. So if you look at this one, there is a common factor of 2 in all of the terms. If we were to common factor that 2 out, we're left with x squared plus 4x minus 12 in brackets. And now we can factor this using the methods that we've already looked at, because the coefficient immediately in front of this x squared term is now 1. So now we're looking for two numbers that multiply to negative 12 and add to positive 4. We leave the 2 out front because we're just factoring this trinomial now. Now two numbers that multiply to negative 12 and add to positive 4 are going to be positive 6 and negative 2. If you were to multiply that out, you'd see you get this back. Multiply it by the 2 and you'd get the original line. So the point I want to make here is if you see a number out front of the x squared term, the first thing you should think is it a common factor of everything? Because if it is, you can common factor it out and then use the easier methods that we looked at before of factoring these kinds of trinomials. But sometimes, often, that won't work. In this case, we've got a 3 here, and 3 is not a common factor of all three terms. So now we need to look at something, we need to look at a different method of factoring. So in this method of factoring, sometimes called factoring by decomposition, the technique is to look at the coefficient of the first term and the last term here, and we need to multiply those two together. So 3 times positive 4, that's positive 12. Now, whereas previously we were looking for numbers that multiplied to the last term, now in this kind of trinomial where there's a number here, we need to look for numbers that multiply to the product of the first coefficient and the last term. So instead of just multiplying to 4, which is the last term, we need to hunt for numbers that multiply to positive 12. The numbers that we find, though, still have to add to that middle term. So that's similar to the method we looked at before. Okay, so we're looking for numbers that multiply to 12 and add to 8. I'm just going to erase these to give myself some space to work here. So multiply to 12 and add to 8. So those two numbers are going to be 6 and 2, both positive. Now, we're going to split this middle term up using the numbers we just thought of, 6 and 2, and we're going to write positive 8x as positive 6x plus 2x. Notice if you add these back up, you get this. So we've decomposed it into these two different terms. And we're going to bring the first and last terms from above down unchanged. So this is what the next line of your factoring would look like. We've taken the first number, or the coefficient of the first term, 3, multiplied it by 4 and gotten 12. Now we're looking for two numbers that multiply to 12 and add to 8, this middle number. We decided those two numbers are 6 and 2. We broke that up into that 8x up into 6x and 2x, and then we brought the rest down unchanged. Now we're going to factor by grouping. So imagine you're dividing the 4 terms like that. We're going to common factor out of the first 2 terms. So the common factor here is 3x, and we're left with x plus 2. And then we're going to common factor out of the next 2 terms. So again, the common factor in this case is 2, and we get x plus 2 in brackets. And it's important to write that plus in front of the positive 2. Now we have a common factor of x plus 2, and as we saw before with factoring by grouping, we can common factor that binomial out. So we get x plus 2, and we're left with 3x plus 2. Imagine you're factoring this whole thing out as a common factor, and you get this. So that is factoring by decomposition, and is how you need to approach a trinomial like this, where the first term has a coefficient other than 1, and it's not possible to common factor it all out.